Hello, everyone. My name is Giacomo Medda, and I'm a PhD student at University of Calgary. Our work uh, regards information retrieval in psychotherapy, and it was a joint work with Dr. Vivek Kumar, Professor Daniele Riboni, Professor Diego Reforgiato Recupero, Professor Gianni Fenu, and Dr. Helaoui. In particular, this work regards the fact of psychotherapy. It is related due to the COVID-19 pandemic, which caused where cases of mental health issues such as depression and anxiety have increased, raising raising the need to provide therapy to a greater number of individuals. The problem is that people were confined in their houses, and the only availability of therapy resources were remote, so such as remote therapy services or documents online. But people do not have familiarity with such topics, and so the research community worked on solution based on natural language processing, for instance, with the chatbots, to support patients to have a conversation helpful for their psychological disease. Still, this type of help is limited by the conversation because is limited by the conversation that starts from the patient, and the patient cannot take documents to read autonomously, so they can find autonomously what can help them so some aspect of the document that they find. Our contributions consider a set of documents of low and high quality used to train a ranking system to predict a relevance score for new unseen documents. So we can rank them based on the predicted quality, such that like our goal is to have the high quality ones over like ranked in higher position. In our case, the documents are represented by therapy sessions. So we have a therapy session between a therapist and the patients. So patients can then take one of the therapy session ranked to see if they see themselves in the patient of the session, and the sentence or the answer, the replies of the therapist can help them too. So for their own problem. Such a ranking system will work by querying a psychological topic, or we can call it psychological disease, such as smoking cessation or reducing alcohol consumption. We then performed a fairness assessment because the topics reflect a sensitive aspect of the patients, and the ranking system should not favor any specific mental health issues. We used AnnoMI for our work, which is a dataset containing about 143 motivational interviewing therapy sessions, whose quality was annotated by experts in the field. These sessions range over 43 topics for a total of 10,000 utterances, and we applied two pre-processing steps. The 43 topics are too much diverse, and so and some of them are similar between them. So I was saying we apply two pre-processing steps. The 43 topics range over. The 43 topics are too much diverse, and some of them are similar between them. So we merge them together, or we assign them to a new broader label, resulting in 8 topics, with their presentation shown by the table for each quality level. The second processing step is more related to the psychological domain. The quality of a session is based solely on the therapy utterances. So we don't need the patient response to the therapist, and we take only them, which are in total about 4,000 utterances. However, due to the low number of therapy sessions for each topic, we simplify the ranking task by considering only the single utterances as documents. This is done based on the aspect that a high-quality therapy session is made up of high-quality utterances. Then, given a psychological topic, the system ranks a set of documents where each document for us is an utterance of this type, like shown in the presentation. We test our dataset over 9 models of different complexity, highlighted the complexity that is highlighted by the different colors of the bullets, with dense baseline and naive as the simplest one. We have also TensorFlow ranking BERT, which is the most complex one, and the other ones can stay in the middle of the complexity level. They were provided by Mesh Zoo library, and the other one obviously by TensorFlow. The fairness assessment was performed under the notion of demographic parity, for which the accuracy utility should be the same across demographic groups. Or in our case, we can we name the demographic groups up as psychological topics. The notion was operationalized with the following formula, which computes an average absolute difference between the utility of each topic and the other ones. And the utility in this case is measured with the popular NDCG. In other words, given the NDCG in the x-axis and the topics in the y-axis, we can see that the utility is significantly different among topics in this toy example. And demographic parity will be satisfied if all the pink bars were at the same level. So we can have different levels, like remarked by these dark purple bars, where the rankings are fair. And so for us, the one that guarantees for us the best result will be the one that guarantees the highest average utility. In our experiments, as the first one, we investigated if the rankers, which are represented on the x-axis, guarantee a good level of utility on our therapeutical data. Analyzing the ranking utility over different relevance levels shown on the y-axis of each subplot could provide insights into the decision-making process of each ranker. The results show that all models reports rankings of high utility on our therapeutical data. As you can see, all the boxes are close to the highest value NDCG. And other than that, we've seen that there is no relationship between the complexity of the models and the higher NDCG average, where we have simplest models also reaching high levels of utility. The second experiment assessed the fairness level of our rankers. In a work, a query represents a psychological disease, which directly reflects the patients that suffer from it. It is then crucial to study whether ranking algorithms exhibit bias towards specific psychological diseases. Even though we have just seen that these rankers, which are there, still represented in the x-axis, are suitable to be applied to psychological data in terms of utility, they do not seem to be reliable to provide fair rankings. Based on the fairness metric in the y-axis for the different relevance levels, we can see that all of them, none of them is really close to the point of 0, where we consider like the fairest result. And also like a really harmful result we've seen is that if we see the first subplot where we tested the fairness of the top 3 items, is not 0. So it means that at least one low quality document is present for some mental health issues and for others not. So it's really, I would say, an harmful result for some patients. However, like for the previous question uncovered a relevant level of unfairness, we have no insights into the utility of the rankings provided for each individual topic. So in these plots for each heat map, which we have one for each relevance degree, each cell represents the NDCG measured on the ranked list provided by a ranker in the rows, and for an individual query topic and the columns. And they are sorted from left to right by average utility across the models. We can see that there is no systematic impact on specific diseases. For each column, we have at least one model that provide a really high utility, which is represented by darker colors. And some different models exhibit high and low ranking utility for some topics. We can see that there is still some impact on on some topics, and we've seen that this is I would say caused by the higher presentation of low quality utterances. Indeed, the topics SC, RIC, AMP, which stay smoking cessation, reducing alcohol consumption, and adhering to medical procedure, are composed by more than 1% of low quality documents, and they are closer to the left side of each map, which are the unfairest results. In conclusion, we can say that our experiments confirm motivational interviewing data is suitable for ranking tasks, and this is shown by all the diversity complexity of the models that we have used. However, the models show relevant disparity across mental health issues, and these results still remarks how it is important to address this issue in the psychological domain. Future works, we make use of augmentation techniques to extend the dataset with more therapy sessions for each topic, so to extend our ranking tasks not only to the utterances, but also to the therapy sessions. In order to improve the ranking methods with such data, we'll explore other factors as the complexity of the patient condition or the length of the utterances to better interpret the results with some interpretability methods. Okay, thank you for your attention. And this is like the source code if you want to check our work. And do you have any questions? Thank you.
Thanks.